Okay, so we're going to begin today by doing a review of integration before we get to integration by parts, which is actually a BC topic, but we're going to introduce it in AB. So our objectives today is to practice integration techniques that we've learned so far, and then we're going to start with integration by parts. Fun stuff. All right, as you integrate, you need to ask yourself some just basic rules, some basic questions. First, when you approach a problem, you want to ask, is this a basic rule? Can I use a power rule or a trig rule or an inverse trig? Secondly, if none of those are an option, can I simplify it so that they become an option? So can I factor? Can I multiply? Can I divide? Do I need to use Pythagorean identity? And finally, the last thing you want to try is use substitution. And remember, when you use substitution, you have to ask, will du be in the original integrand? That's very important. So what I think you should do, in your notes, you have 8 problems. I would suggest pausing this video, trying the 8 problems, and then coming back and watching the video to get the answer. Okay? Well, welcome back. So I'm going to go through most of these pretty quickly because I think most of these you probably can do. In this first problem, the way I want to attack this, I can't use a rule because there's no quotient rule in integration. So let's simplify it by dividing by x, which gives me an integral of 2x plus, remember this is x to the 1/2. I subtract exponents and get x to the negative 1/2. And then after that, it's just a simple integration. So that gives me, I'm using the power rule now. And remember your cookies, okay? For this one, I can't really simplify it. Again, there's no quotient rule in integration, so then I'm going to use substitution. If I make u equal to the natural log of x, then du is equal to 1 over x dx. And look at there, we have that in our problem. So now this is just a matter of integrating u raised to the 1/2 du. Using the power rule on that, I get u to the 3/2 times 2/3, which is 2/3 natural log of x raised to the 3/2 plus c. When I look at this, this looks similar to tan inverse, and it is tan inverse. Remember, I have to make a is going to be the square root of square root of 11, and then I just apply the formula. So it's 1 over a, the tan inverse of u, in this case u is t, over a. This one may have thrown you, but just recognize this is simply a constant, okay? And this can be written as x to the 3/4. So I'm just going to, since this is a constant, this just becomes pi to the radical 2 times x plus, using the power rule on this one gives me x to the 7/4 times 4 over 7 plus c. Okay? So if you recall back when we did rational expressions, when we integrated rational expressions, if the exponent on the top is bigger than the exponent on the bottom, we need to do a long division. But as I look at this, I can also notice, there's a dx there, I can also notice that this can be factor, x minus 3, x minus 4, all over x minus 3. And look at that beautiful thing that happened. That cancels, so now I just have x minus 4, which is x squared over 2 minus 4x plus c. Easy peasy. We want to remember with absolute value that the best way to do that is to do it graphically. So this is -3, and we're going to 1. So what we simply have to do is just find the area under the curve. So we're finding the area from here to here of this shaded region and this shaded region. Okay? Okay, so to do that, I have to remember that the area of the curve is 1/2 base times the height. And if I call this 1 and this 2, then the area of 1 would be 1/2. The base is the difference between, this is -3, this is -4. The base is this distance, which would be 1. The height, I get the height by evaluating -4 in this expression. So if I put -4 plus 3, I get -1. Take the absolute value of that, I get 1. So this area is 1/2. Area 2 is 1/2. I'm going from -3 to 1, so that's 4 units. And to find my y value, I evaluate this expression at 1. So I get 1 plus 4 is, 1 plus 3 is 4. So this is 8. So the total area is 1/2 plus 8, or 8.5, or 17/2, if you will. I'll accept either of those answers. Okay. Now, these last two were probably the most tricky of these, and I think you've seen some of these earlier, but if not, we just kind of go over these quickly. So I'm going to do these a little bit slower. My first instinct is, first of all, you cannot multiply this into this radical. So don't even try that. That's unicorn math. We're going to talk about that later. That's unicorn math that you're making up. Okay, so what I do want to do is I want to let u equal to x minus 1. Then du is equal to dx. I had written this correctly. There should be a dx there. Now, I still have to do something with this x, because everything has to be in terms of u. So I have this x just hanging out. Well, I can look at this and say, well, x, if I solve for x in this expression, I get x is equal to u plus 1. So now I'm going to change everything in terms of x. So this x becomes u plus 1. This becomes u to the 1/2, and du is equal to dx. So everything now is in terms of u. I can then distribute this u to the 1/2. Now I can distribute into this parenthesis because it's not being raised to an exponent. So I can distribute into this parenthesis. So this gives me u to the adding, so 1.5 is 3/2 plus u to the 1/2. And now I can apply the power rule, which gives me u to the 5/2 times 2/5 plus u to the 3/2 times 2/3 plus c. And then now I need to go back and replace my u's, so I get 2/5. U is x minus 1 plus 2/3 x minus 1 to the 3/2 plus c. Okay? Now, this next one is going to be similar to this. So if you want to take a moment, pause the video, and try it on your own, I would suggest that. If you didn't do it the first time, pause the video and try it. Okay, here we go. U is equal to 3x minus 1. Du is 1/3 dx. Okay? So, and again, there's the dx here. I've dealt with dx. I've gotten this. I still have this x. So I need to do something with that. So I'm going to solve for x in terms of u. I'm going to add 1 to both sides and then divide by 3 to get x by itself. Now I've got a lot of stuff out here, so I'm going to get rid of some of these constants. So let me start by writing the 2 on the outside. X became u plus 1 over 3, and this became u to the 5th, and dx became 1/3 du. I wrote that wrong, but I think you know what I meant. This should be du is equal to 3 dx. And then 1/3 du is equal to dx. I was writing too fast. Okay. Now, I can also bring out this third here, just to make my life easier since I'm multiplying it by everything. I'm just going to pull out this third, and that's going to give me 2/9. The integral of u plus 1, u to the 5th. Then I'm going to distribute the u to the 5th to get u to the 6th. And then, of course, I can integrate this all day long because this becomes 2/9 on the outside, 1/7 u to the 7th plus 1/6 u to the 6th plus c. Okay, so here we go. Let's just clean this up. So we have 2/9. No, yeah. Well, let's go ahead and distribute that 2/9. So that's 2 over 63. And then u is 3x minus 1 to the 7th. Plus, distributing that again, I get 2/9. The 2 and the 6 cancel, so I get 1 over 27. I think my math is right there. And then u is 3x minus 1 to the 6th power plus c. And that's my answer. Okay? So now we're moving on to integration by parts. So we're going to start BC. This is very exciting. So I want you to pause this video and just quickly do this free response question. We have to just keep our skills on past topics. So pause the video, do this free response, and then come back. Okay, welcome back. I hope you finished this free response. And the answers are, they did it two different ways. One, this is probably the easiest, most straightforward way, but then they also showed you that you could have done right minus left. And then, of course, at the bottom, you're going to use the disk method. Remember your pi. Okay, integration by parts. This is an exciting topic. Integration by parts. This is the formula, so you want to take a moment, pause the video, and write the formula down, and I'll explain it in a minute. Okay, integration by parts is the product rule for integration, if you will. The u you choose, you want to be something that differentiates easily. Generally, it will differentiate to 0, usually, not all the time. dv, on the other hand, has to be easy to integrate. So when you're looking at a problem, you have to determine which one is u and which one is dv. And then once you have that, then you have uv minus integral of v du. To help you choose u, I like to use the mnemonic device isolate. So you always want to start by, if inverse trig, if it has inverse trig, you want to use that as your u. If it has logs, then that becomes your u. Then algebraic, then trig, then exponential. Now, this is not a hard and fast rule. This is just a suggestion. So you don't have to follow this rule. This general rule just makes your life easier when you're trying to determine what to choose for you. Okay? So we're going to do 3 examples in this video, and then we're going to move to the next video. Okay, so remember the formula is u dv. So you have to determine which is u and which is dv. Well, x, if we use isolate, okay, we don't have any inverse trig, we don't have any logs. Algebraic is the next one, so x is our algebraic term, so we're going to let u equal to x, which makes, the only thing that left then is dv has to equal to cosine x. Okay, and the formula is uv minus the integral of v du. Okay, so we start, so if this is u, we need to find v. So let us do this. So if u, let me rewrite this. Okay, so dv is equal to cosine x. So then du is equal to dx, and v is equal to positive sine x. I know you thought I was going to make a mistake there, but I did not. Okay, so it's uv minus the integral of v du. Okay, so we integrated dv to get v. We took the integral of cosine x, which is sine x. Okay, so then we write uv minus the integral of v du. And in this case, du was simply dx. And so now we can integrate this again. We don't need integration by parts to integrate that. We know that that is negative cosine x. So then we have x sine x minus negative cosine x. So we have x sine x plus cosine x plus c. I'm just checking my formula. uv minus v, the integral of v du. That's what I got. Okay? Now this one is a little different because it only seems like there's one expression there. Okay? So we don't have much of a choice. Using isolate is not an inverse trig, but this is a log. So using isolate, u would be the natural log of x. Well, I guess you're wondering then what is dv? Well, dv is going to be dx. Okay? So remember the formula is uv minus the integral of v du. And this is the integral of u dv. So we have to make one u and the other one dv. Okay? So if this is u, then du is 1 over x dx. To find dv, I integrate dx. So integrating dx, I get v is simply equal to x. Okay? So then remember it's uv. So I'm going to write that as x, natural log of x, minus the integral of v du. Well, that works out well because that becomes x natural log of x minus dx because the x's here cancel. And then integral of dx is simply x. Now, this is something that you need to memorize because this comes up often. And if it is a multiple choice question, which more than likely it will be, you don't have to prove it using integration by parts. You can just give the answer. Okay? So you need to memorize this. And know this one. We actually did a problem like that earlier in the year, and I asked you guys to look it up. So you need to know that. Make sure you memorize it. All righty, one more. Now we're going to do this problem. If you notice in your notes, this problem appears again. When we do it again, we're going to use the tabular method to do it. But for now, let's just use the regular method, okay? So remember, we have to make our problem the integral of u dv, and that's equal to uv minus the integral of v du. Okay? So we need to determine which one is u and which one is dv. So we use isolate again. There's no inverse trig, there's no log, there is an algebraic. So we're going to let u equal to x squared. Then that makes dv equal to e to the x. Now that actually works out well because it's easy to integrate e to the x. All right, so that gives me du is equal to 2x dx. And v is equal to e to the x. So remember, it's uv minus the integral of v du. So I'm going to put that 2 there and write that x dx. Okay? Now, can we integrate this? No. not without using integration by parts, so we're going to have to use integration by parts again. Now, the biggest thing about this is keeping up with your negative. Keeping up with your signs are very important. Okay? So we have x squared e to the x minus 2 times, okay, so now we have to do u and dv again. So once again, I'm going to let u equal to x, which makes du equal to dx, and I'm going to make dv equal to e to the x, which makes v equal to e to the x. So then I have minus 2 times uv minus the integral of v du. In this case, du is simply dx. Okay? So this gives me x squared e to the x minus 2x e to the x plus, because that negative times that negative becomes positive, and the integral of e to the x, is simply e to the x. Let's see. Okay? All right, there is the second video. We'll continue this, and it will do more problems. The key to this is just practicing. So please watch video 2.